You ever seen a super smart AI pull off something amazing, and then, like, an hour later, it makes the exact same dumb mistake? It's it's so frustrating. But what if AI could actually learn from its mistakes, like we do? What if it could build a playbook of its experiences that just gets better and better over time? Well, a new paper tackles exactly that, so let's get into it.
I mean, it's a total paradox, right? We've got these incredibly powerful AI agents that can write code, use apps, but they act like these super talented rookies. They've got all the potential in the world, but they just don't seem to learn from the game tape. They keep tripping over the same problems again and again. So, what is going on? What's holding them back?
Well, the whole problem is in how we coach them. The main way we do it is called context adaptation, which is just a fancy way of saying the instructions we give an AI before it starts a task. But, as it turns out, our current coaching style has two gigantic flaws that are basically preventing these AI rookies from ever becoming seasoned pros.
Okay, so this coaching style has two big issues. First up, something called brevity bias. This is like giving the AI a playbook with just one page that says, hey, play well. It's just too vague to be useful. But the second flaw, context collapse, is so much worse. This is like taking the playbook after every single game, chucking it in the trash, and trying to rewrite the entire thing from memory. You're just guaranteed to forget the important stuff.
And that second problem, context collapse, is where things get really, really weird. You'd think that trying to make an AI learn from its experience would always make it smarter, but sometimes the very act of trying to learn can actually make it perform worse. I know, that sounds totally backwards. How can learning possibly be destructive? Well, when an AI tries to take all of its past experiences and summarize them into a new single set of instructions, it can fail catastrophically. And get this, the data from the paper shows just how bad it is. In one experiment, an AI started with a really detailed playbook, over 18,000 words, and it had a solid 66.7% accuracy. But after just one attempt to learn and rewrite its own playbook, it collapsed all of that knowledge down to a measly 122 words. And the result? Its performance absolutely cratered to 57.1%. That's even worse than if it had no playbook to begin with. As the researchers put it, the AI's accumulated knowledge can be abruptly erased. It's like digital amnesia. All that experience it worked so hard to get, just poof, gone. This is the huge problem they set out to solve. So how in the world do you fix this catastrophic forgetting problem? Well, the researchers built a whole new framework to do it, and they call it Agentic Context Engineering, or just ACE. The best way to think about ACE is as a complete, intelligent coaching system that's designed to create a playbook that evolves and never, ever forgets a lesson. So, instead of having one AI try to do everything, AC breaks the job down into three specialized roles. First, you've got the generator. That's the player on the field actually trying to do the task. Then there's the reflector, who's like the team analyst watching the game tape to figure out exactly what went right and what went wrong. And finally, you have the curator, the head coach, who takes all those insights and makes these small surgical updates to the playbook. And this is the fundamental shift, the big idea. The old way meant rewriting the entire playbook every time, which was slow, expensive, and made the AI forget things. The ACE way is completely different. Instead of a total rewrite, the coach just adds one new, smart page, or maybe tweaks an existing one. All the old knowledge is preserved, while new wisdom is added super efficiently. Okay, so the theory is really cool, but does this smart coaching system actually work? Does it lead to a championship-level performance out on the field? Well, the results are pretty staggering. On a really tough benchmark where AIs have to use real-world apps, the best of the old methods kind of topped out at around 46% accuracy. But with AC as its coach, the AI's performance shot up to almost 60%. That is a massive, massive leap in what it can do. So this leads to the ultimate underdog question. We all know bigger, more expensive AI models are usually better, right? But what happens if you give a smaller, less powerful AI a truly world-class playbook? Can David actually beat Goliath? And the answer is a huge, resounding yes. In what has to be the most exciting result in the entire paper, a smaller, open-source AI, coached by the ACE system, was able to match the performance of the #1 agent on the leaderboard, an agent that was powered by the industry giant GPT 4.1. This proves that a smarter playbook can be just as important as raw power. It's a game changer. And it's not just about being better, it's about being faster, way faster.
The AC system adapts and learns nearly 87% faster than the old methods. It's not wasting time rewriting the entire playbook from scratch anymore.
And all that efficiency, it translates into major cost savings. Because the whole process is so much smarter, it costs 84% less to run. This makes the dream of a truly self-improving AI way more practical and accessible for everybody, not just the giant tech companies.
So, what does this all mean for the future? Well, we're moving away from thinking about AI instructions as these static, simple prompts and shifting towards something much more dynamic, something that's alive.
This quote from the researchers just perfectly captures this whole shift in thinking. The instructions we give an AI shouldn't just be some short summary. They should be a rich, detailed, and constantly evolving playbook, one that's filled with strategies, expert knowledge, and all the lessons from the past.
So, when you boil it all down, what this means is that ACES gives us a clear path toward what we've all been hoping for, truly self-improving AI. It makes them more reliable, way more capable, and it dramatically lowers the barrier to entry, letting smaller, more efficient models go toe-to-toe with the best in the world. This really is a fundamental step forward.
And that leaves us with a really fascinating question to think about. Now that we have a blueprint for an AI that actually learns from experience, what's the first complex real-world job you'd want to see it master? A personal assistant that finally gets better at helping you? A scientific researcher that learns from every failed experiment? Let me know what you think down in the comments.